Okay, hello everyone. I hope you are listening to me well. Welcome to this webinar. Today we are talking about getting started with data exploration in Python. My name is Clarice, and this is a webinar for the Machine Learning Scholarship Program for Microsoft Azure on a study gen of Udacity. So let me introduce myself. Very nice to meet you. Today, I work as a lead software engineer in a huge company in the electronics and semiconductors industry. I have more than 9 years of experience with software engineering. Today, I work more with C++, but I have also experience with other programming language, and I'm working more focused on high performance systems and product innovation by using agile methodologies. And I have also some experience with web development. But what I must say, and I must be honest, is that area of data science and machine learning is actually very new for me. So this is something that keeps me motivated because I'm learning lots of stuff. I'm learning, having the opportunity to learn a lot on this program with you all and having the support of this amazing community. So I hope I can bring some things that I've learned so far for you and help other people as well, just like I've been helped a lot in this program. So no more talking about me. Let's go over the Python stuff. So let's just start discussing why Python is a good programming language for data analysis. So first of all, Python has a very large community, and it started on the early 90s, and it developed a very large and active scientific and computing community overall. Python have many applications, not only in data science and machine learning, but also as a backend programming language for software development, and it's used both in academia and industry. Python is a language that integrates well with other languages. So many systems that have their legacy code in languages like C++ and C and Fortran code, they are easily integrated with Python code and Python data. And uh, in last, here we can see that Python is also a very versatile language because what people see is that Python is not only used for example, production systems, but it's also a very good language to do prototyping and trying stuff when we are actually handling with data. So uh, there are some essential Python libraries when we talk about data analysis and data exploration that everybody should know and should be familiar with. The first one is NumPy. NumPy, it's a library that contains a very efficient data structure called ND array. So this is a type of array that has a good implementation under the hood, which makes it be very fast when we talk about arithmetic operations and linear algebra operations. And for data exploration, the most famous library that we can think about is Pandas. We will see Pandas in action in a minute, but this is a library that is used to open and handle structured and tabular data, and it's very fast, easy to use, and allows us to do many different things. So we have lots of flexibility with Pandas. Another library that's very good and very popular is Matplotlib, which is known for allowing us to visualize data in many ways. There are other libraries for visualization that are built upon Matplotlib, for example, Seaborn that we are going to use today as well. And also, we have scikit-learn. Scikit-learn is a library that contains many machine learning models ready to use and algorithms already implemented for us to use. So it has, for example, logistic regression, supporting vector machines, random forest classifiers and clustering algorithms and many others that we can use to create models and predict the value for data that we want to predict. So I expect that everybody that is starting with data analysis and machine learning had heard about Kaggle, but if not, Kaggl is a very good platform. It's a platform that is used to practice machine learning problems. Definitely, you should take a look on it. They share very good context about and data sets about machine learning, and it's free to use. Many companies actually post challenge there, so some companies post some challenge, and everybody can go there and try to solve the challenge, use machine learning and data analysis. And they have many built-in tools on their platform for also for data visualization. They provide many data sets, notebooks, and they have an amazing community, just like the one that we have in the course. So today we are going to see to put our hands on a Kaggle challenge, which is known as the Titanic challenge. So the Titanic challenge is a competition where we have data about the passengers of the Titanic shipwreck that was really famous and became a movie, as you probably know. And we are going to use machine learning to create a model to predict the passengers who survived and the ones that did not survive. And for that, we are given a data set with variables describing the passengers. This data set will contain features like age or sex or which class the passenger were on the boat. And for actually, this data set is divided in two parts, which is the training data and the test data. And we are going to see that the training data have it's more complete because it has a column with the survived uh, information, and the test data doesn't. So no more speaking on slides. Let the madness begin. Let's go on the challenge itself now. So let's see here. Oops, sorry. So here we have the main page for the Titanic data challenge on Kaggle. And here they provide an overview of the data. We have the columns of our data set described here. So first of all, we have the survival, which is the passenger survived, no or yes. We have the passenger class. So if the passenger were in the first, second, or third class, we have the sex, the age, and the number of siblings and spouses aboard the Titanic, the number of parents or children about the Titanic, their ticket number, the passenger fare, the cabin number that this passenger were, and the port where the passenger embarked, because it might have embarked in the passengers embarked in three different places. So we have a C, a Q, and an S. So that said, let's go over the hands-on challenge. So when we start, before we start, all the things that we are going to do here today is based on this tutorial that I'm gonna leave the link below here. So I highly encourage you to check this tutorial. It has many more things that we are going to do here today. And here, when we start a challenge in Kaggle, it gives you the data, some data. So we'll have our input data here. This gender submission is an example of an input. The test and the training data are here. So we start our challenge by actually importing some libraries. So we import the data for NumPy, for Pandas, for Matplotlib, Seaborn, which is the data visualization library based on Matplotlib. And we will also see in the end, we will import the scikit-learn for training the data. So we started here by listing the files that we have in our input folder. And and the first thing that we do is that we use Pandas PD. This is kind of a pattern, so you will usually see the pandas library imported with the name of PD to get the training data, and the head method here prints the first five items of the data for us. So this is basically what we have what we have seen on the columns that we have seen before. So we have data about the embark, the fare. We see some data now here, which is interesting. The ticket doesn't seem like great information for us. The number of parents and children, siblings and spouses, ages, sex. Okay, many things around. Okay, let's import now before that, we have the training data here, and pandas provide this info method for us to see a little bit more information about the data that we have. So it lists the columns, it lists the number of entries that we have in the total, and it shows us the number of data that is not null around the passenger ID, name, sex, age, siblings, spouse, and so on. And now let's move forward and import the testing data. The testing data is basically the same data that we have above, but it doesn't have the survived column. So here we have less data and we don't have the survived column. And we can get the info for this guy here as well. So let's see test data.info. Yeah, so we have less entries and we have some entries that are no, some others that are not, some entries that are numeric, some others that are not. Okay, so let's start having fun with this data now that we saw it. Let's start first of all creating a concatenation of the two data sets that we have and create a data set with everything together to make it easy for us to manipulate the data. So let's concatenate the two data sets that we have and save it in an object called dataset and see the information for this guy dataset. So the dataset will have everything put together, and only the guys that have the survived data that came from training dataset have the survived data filled on. And let's start exploring this. So let's start by using matplotlib, and we can start plotting data about where we have no values around. We can see that we have many no values around. So let's see this guy here. So here I'm going to plot this type of plot, which is this one that we are seeing below, and let's see in the data set where we have no values in the full data set. So on survived here in the yellow part, the things are null. We can see that we have many ages that are also null around. We have some fares embarked and some cabins that are null as well. So first of all, I think it's easy if we start with the numerical features that have no values. So we can go looking for age first and try to come up with a good strategy to fill missing data on the age fields. So let's start by plotting the correlation between the survived and other data around. And we can see here on this correlation matrix using matplotlib that we have here the correlation here that the more close to yellow we get, the more correlation we have, and the feature that is more correlated to survived is actually the fair. So another thing that calls my attention here is that we have a high correlation between the number of parents and children and the numbers of siblings and spouses. And another thing that we see is that the feature that have more correlation with everything else, the numeric feature, right, is the fair. So fair is have a decent level of correlation between the other features, numerical features that we have plotted here. Okay, that said, let's start exploring the age, how we are going to fill the age missing data. So let's try seeing the relationship between in a different way between aged and survived. So we are going to plot a distribution, the distribution between ages and survived. Uh, uh, here. So what we can see is that we have people who survived. They are on the orange a part of the graph, and the ones that didn't on the blue. So we see that we have a few more young people that didn't survive than the ones that actually survived. And we see that old people, most of them did not survive to the shipwreck. Okay, uh, we let's start exploring now another thing that uh, what's the relationship between the age of the passengers and the class that they were? Let's see if we find something here. So we will plot a similar graph here and let's see what we get. So we see that most young people were actually in the third class, as you can see, and people who are aged, more aged, were more concentrated in the first class. This kind of indicates for us that we have a relationship between ages and the class that the person were. So let's try to explore this a little further with a box plot. Let's see here. Okay, so here now, this is a different type of plot where we can see easily that people who are younger, they are more concentrated on on the third class, just like we saw above. But then we can see that the median of the age value of the person, the people here is like 24, 25, something like this. And we can see that again that people who are um, more aged, they are fairly distributed on the first class, and the median for the age is like, I don't know, 37, 38, something like that. So this could be a nice strategy to filling our age missing data, because we see that people who are young, they are located in the more located in the third class, and the other people who are more old are in the first class. So let's try to use this the median that we get in this graph to fill the data. And now here it comes another very good feature of pandas for data transformation. So let's focus here in the end. So we have this, want to fill the age column of our data set, and for that, we will try to apply a custom method, which we are calling age input, taking by base these two guys here, these two columns of our data set, age and class, and looking on the axis one, which is the column axis. So here what we do is that basically we look on the age of the person, and if the age is null, we will substitute the value null for the mean values that we saw above. Otherwise, we will keep the same age that the person has already filled there. And after executing this, I expect that we won't have any missing data on age anymore. So let's plot again our distribution of the data in the data set. Good, good. So here, no more missing data on age field. And now let's handle the other numerical field, which is fair. So fair here seems to have only one or two. Let's see, uh, data who is missing. Uh, so let's check. Oh, yeah, only one. So fair has only one data that's missing. So it's fair enough that we use the median value of the entire column to fill this. So let's call fillNA, which is a method that is on look from pandas to and pass the median of the values that we have on this column to fill this guy here. And then we can plot everything again. Let's see this guy again. Okay, no more missing data on fair. So I think with that we are done with numerical features. So now we need to take a look on non-numerical features. So let's see now what we have on the non-numerical features. Let's remember. Let's how is the format? Whoops, sorry. Data set dot head of our data set again. So here, okay, we have the embarked, which has one or two missing values around. And we have another important feature that is non-categorical, that we have the names, the sex, the cabin, and the embarked. Um, for this tutorial, we are going to focus on sex and embarked features on the non-category, on the non-numeric features. But you can feel free to try yourself more exploring the other data after that. So let's start by checking the relationship between the embarked people, where people embarked and if they have survived. So as we can see, people who embarked in the sea place here, they have more probability to survive. And let's see how many we have from each class here. So value counts will provide for us how many data we have from each guy here. So we have 900 values, 900 people, 14 people that embarked on S, and the other we have much less people. And let's see again how many no we have for embarked. So we have two, okay, two, only two. So let's fill those two guys here with the most frequent value that we see in our data set. So let's fill those guys, fill NA with the most frequent value, which is S, okay? And we are almost set for going to our training classifier. Now we only need to transform the data that is not numeric into numeric. So let's do that. First, with embarked, and for that we will use the one hot encoding approach to transform the embarked values on into numeric values. So here what we do is that we use the get dummy methods on pandas, um, and we use the as input the column of our dataset embarked, and we concatenate the result of this method here on our dataset, and we drop the original column. And so let's see how we end up stuff here. So okay, so here we don't have the embarked column anymore, and instead we have the Q and S columns. So if the person embarked on C, it will have a 0 and 0 around here, which is okay. And this extracted all the meaning that we needed here. And now let's do the same for the sex column. So here we will see, let's encode this guy here into numbers. So we actually need only one column for the sex guy, and we will do exactly the same that we did for embarked. So here is the same code, but instead of doing this for embarked, we are doing this for sex. Let's see how we get in the end. Okay, so now we don't have the sex column anymore. We have only the male column. And for those who are male, we get 1, female 0. Good enough? Uh, let's explore a little bit how the sex feature relates to the survived uh, hate, so survival rate hate. So here we are plotting a count plot using Seaborn, and as you can see, the interesting thing is that most people who not survival are male, while most people who actually survived are female. So this is actually this looks like a very interesting feature in our for our model. So that said, we are finally ready to go to create our model, train our model, and get a machine learning prediction for that. So let's start by splitting our data set again into training and test. So let's split this guy here, the first 891 lines, and with all the columns, let's save it on the train data. And as you can see here, survived looks like a float variable, and we need this as int as an int type to for our classifier to be able to understand it. Okay, and now let's get the rest of the data and include it on test here data. And we need to drop the survived column because this guy here is actually all, although right, doesn't make any difference. This is what we are trying to predict. Okay, so here, what we need to do now is that we need to train our data. There is one step missing that is importing our library around. And yeah, I had done it before, sorry. And here, so we are going to, here we have the training data as survived the and we select the features that we are going to use as input to our classifier. We split the data of training and testing, and we create our random forest classified model. And the output of this guy will be a data frame itself, where we have the passenger ID and the survived. And this is something that Kaggl requires us. So we have a similar output format here in this example. So passenger ID and survived as well. And okay, um, now the only thing that we are missing is actually to save the data. And here we'll be able to download our results and send this to Kaggle to see how we did. So let's see, let's submit this prediction here. What is the name of the file? 3. As you can see, I've done it a few times to prepare for you. Okay, let's make the submission. Okay, so here's our score. The best we can get is 1. So this is not bad, right? We can improve, of course, but this is already a great result for us. So yeah, I think we are almost done. And before ending, I want just to do a quick recap of what we did today. So we explored uh, why Python is a good language for data analysis and exploration. We saw some libraries like pandas. We talked about Kaggle and we did the hands-on challenge on Titanic challenge there on Kaggle itself. So the material that I suggest for you to take a look to next steps is the one that I used as reference for this presentation is this book here, Python for Data Analysis. This is an excellent book, amazing book, and the author of it is actually the guy who created the Pandas library, so really worth it to read. And almost that everything that we did was based on this tutorial, and I highly encourage you to try it on yourself again. So yeah, if you followed me and if you stick with me until the end, thank you very much for your time. I hope this was useful for you, that you learned something today, that you had fun. I had lots of fun while preparing it. Thank you very much. And if you have any feedback and you think anything could improve, and if you have any suggestion at all, please leave it here in the comments. I will be glad to talk to you. Thank you very much for your time and see you later. Bye bye.